Good afternoon. I hope you've all been having a great time at Google I/O this year. My name is Michael Bleigh, and I'm one of the engineering leads for Firebase. On a personal note, I'm really excited to be here giving this talk today because everything that I'm going to talk about are things that Firebase has been working on for years, and now they're finally all launched, they're public, and I get to show you what they can do. It's a real honor. So, what are we talking about today? Everybody's heard about generative AI at this point, but there's a difference between hearing about it and putting it into action. And if there's one thing that I want you all to take away from my talk today, it's that you don't need to learn a new discipline to use Gen AI. When I first started working with Gen AI, it was really intimidating. There was all kinds of terminology like context windows and tokenizers and embeddings and a bunch of stuff that just seemed really foreign to me. It seemed like the realm of really smart math people. But the more that I worked with it, the more that I realized that these powerful tools are available and accessible to anyone if you just understand a little bit about how to use them. Today, we're going to talk about three things. First, we're going to explore new ways to build apps using PostgreSQL using Firebase Data Connect, our brand new backend as a service powered by Cloud SQL. Second, we're going to demystify Gen AI development and make it practical for everyday use. Gen AI doesn't have to be something you build your entire app around. It can be something that you add here and there as a delightful little feature, or to improve your onboarding experience. And finally, we'll explore how to deploy a working Gen AI feature to the cloud using Firebase App Hosting, our brand new hosting platform that is built for modern frameworks like Next.js and Angular. So, I said we're going to be talking about Firebase Data Connect. Data Connect allows you to use a declarative data model to define how your application behaves. You supply the data model and the queries that you want to write, and Firebase will automatically create a Postgres database schema that maps to your data model, a secure API endpoint that allows clients to call your data model, and finally, type-safe SDKs that give you end-to-end developer experience to just drop into your application. To build our Gen AI features, we're going to be using Firebase Genkit, our new AI integration framework that is completely open source and built from the ground up for app developers. Genkit's goal is to make building with generative AI feel like building any other kind of feature for your app. You don't have to learn a new discipline to use Gen AI. Finally, we'll be deploying our finished product to Firebase App Hosting, our new app hosting platform that is integrated with Cloud Run, Cloud CDN, and Git so that all you have to do to deploy is push. All right, that's enough talking. I think it's time to get to some code. I've been working on a travel app called Compass, and this is what my app looks like right now. I have a home landing page, and I can say, I want to find my trip. That gives me the ability to select a continent, the dates that I want to travel, how many people are traveling with me, and then I can select from a variety of destinations. Let's say that I want to head to Bhutan. And then once I select a destination, I can choose activities that I find interesting at that destination. That gives me a vacation itinerary that I can then share with my friends. Now, I'm happy with a lot of aspects of this application, but the onboarding experience really leaves something to be desired. There's not much of a call to action here besides this Find My Trip button at the bottom, and I've noticed that a lot of people visit my homepage, but they don't convert and start using the application. So I have a couple ideas about how I can improve my onboarding flow First, by using the querying power of Data Connect, and then by integrating generative AI. First, let's look at my application's data model. You can see that I have two types here. Oh, sorry, I'm on my queries. There's my types. I have two types here, destinations and activities. Both of these are mapped to tables in my Postgres database, simply by adding the table directive to my defined type. You can see that each one has a number of columns that are defined by the fields. And in each of these, I can just use native data types like string or timestamp. I can even set defaults like the current server time when the field is created. I can also query this data. So here I have a list destinations query that maps to the destination type in my database. I can run that locally, and thanks to Data Connect's integrated extension that works with both VS Code and Project IDX, I can see here's a list of destinations. I can specify variables to further narrow this down if I want to, but right now, let's talk about that feature that I want to add. This static landing page might convert a lot better if it was more actionable. So what I want to do is be able to feature certain destinations and say, hey, maybe you should try a trip to this location. So to implement that, I'm going to add a featured at timestamp to my data model, and I'm going to hit save. And something that's really cool about the Data Connect developer experience is if I open up my SQL database and I navigate to my tables and look at destination, featured at has already been added to my local database. You can see that as soon as I hit save, it detected the difference between my current schema and what it needed to be and automatically migrated. This makes it really easy to develop quickly, even though I'm using a schema-based structured relational database. If I remove that column, it immediately drops back out of the table. Add it back, there it is. You can iterate really quickly with Data Connect, and you don't need to worry. Your local data model just updates automatically. Okay, so now I want to create a homepage list of featured destinations. I need to write a query for that. So I'm going to start with my list destinations as a basis, and I'm going to say list featured destinations. I don't need the same variables because this is just going to be a query that is on my homepage. And here I'm going to add a condition. Now you'll notice that as I'm typing, I get rich auto-completion of everything. So I added a featured at column. There it is. And I want to feature destinations where the featured at is not null and the featured at is less than, there it is, the current time. You can see here that I have less than underscore time. When you see an underscore in a Data Connect field query, that means that you're using server values. Server values allow the server to inject context-sensitive request information, such as the current user's ID or the current time, into your query. So that means that I can be sure that this query will always be based on the current time. If I run this locally, you'll see I get an empty result set because I just added this column to the database and I don't have any featured destinations. So now I'm going to jump over to my admin query. And you can see I have set up featured destinations, and I've pre-selected Alaska, Fiji, Kyoto, Corsica, Grand Canyon, and Marrakesh as destinations I want to feature. You'll notice that in addition to just saying the current time, I can also perform a little bit of date math here. So I'm going to feature Alaska tomorrow, Fiji today, and the other locations in previous days. I'm going to go ahead and run this. It succeeded, and let's go back and run my featured destinations query again. Okay, we got Corsica as the first one because I forgot my order by. So I want to also order by featured at descending. And now the most recently featured item will always come up first. So you can see that Fiji, which is the one that I featured today, is the first result. So that was a really easy way to build a new query for my homepage. How do I integrate this into my application? Wouldn't it be great if I could be in my Next.js application and just type something like list featured destinations, and that's all I had to do? Well, with Data Connect, that actually is all you have to do. Whenever you define a query in Data Connect, we automatically build a type-safe SDK for each query that you write. So I have list featured destinations. I just need to pass in my Data Connect instance. And I can just say that the data from this will be a variable called featured, and I'm going to wait on it because it's async. And there we go. I've now brought this into my application, and I have featured data. Luckily, my team has already been working on the UI for this, so all I need to do is comment out the title card animation and swap it out for my featured destinations. And now I can open up a preview of my application. And when it compiles, we're going to see whether my new feature is implemented. There we go. So now I have 5 featured destinations of Fiji, Kyoto, the Grand Canyon. Just like that, I've added a new feature to my application. But that's a pretty simple query. I'm just pulling a few fields. You could do that with almost any database. Where Data Connect really shines is in using the power of a relational database to build complex queries. So I have my list featured destinations query, and I want to add in a little bit more to this UI to really pull people in. So since I have activities for each destination, let's pull in a couple activities. You can see that I have this auto-completed field of activities on destination. We automatically create these relational fields for every foreign key reference that you define in your data model. And so I'll just pull in the first two activities for each location. We'll pull in the ref, name, image URL, description. We'll just pull in a few data points about it and save that. I'll run this query again. And now you can see that in addition to the information about the destination, I get a nested list of activities under each destination. So I've just written a join query in about 5 seconds. And if I look at my UI and I tap on one of the destinations, you can see that now, each time I tap on a destination, the activities for that destination pop up, and now I can go forward and plan my trip. So this feels like a much more engaging experience for onboarding than my previous static landing page. But I want to go a little bit further. I have this find my trip down here, but that just gives me a big wall of selections where I have to pick which continent and then I have to pick a destination. Wouldn't it be great if my users could just describe the kind of vacation that they want, and I'll just serve those ideas up on a platter for them? Well, we can do that using generative AI. To bring generative AI into our application today, we're going to use Firebase Genkit. Genkit, as I said, is an integration framework that makes it really easy to bring Gen AI into your application. So I'm going to type Genkit start, and that is going to boot up the Genkit developer UI. You can think of this as your playground, debugger, and other things for generative AI features. I'm going to click to open it, and you can see it opens up here, and now I can just start playing around. I've installed the Vertex AI plugin, so I have access to all of the models from Vertex AI, and I'm going to choose Gemini 1.5 Pro. Because it occurred to me, wouldn't it be cool if users could not just describe the vacation they want, but give me an inspirational image of the kind of vacation they want? So let's just try a test prompt. Let's say, describe a dream vacation based on the following inspiration. Suggest 3 possible locations. Inspiration, and we'll add a picture. I could use a little time on the beach. Now, when I hit run, this is calling the Vertex AI Gemini API. And it's calling that through the same code paths that I can use inside my application. The nice thing about Genkit is that it really blurs the line between the kind of hosted playgrounds you might have used like AI Studio and something that's actually using your application's code. So here you can see that it described 3 possible locations, the Maldives, Bora Bora, and Turks and Caicos. Those all seem like pretty good places to go. So let's bring this into our application. Genkit also comes with a prompt text format called .prompt. So I can export this prompt as a .prompt, copy that, go back to my application, and just paste that in and save it. And now I have a suggest trip prompt that is going to do the same thing that I just did in the playground. Now, let's just pretend that I spent a little time tweaking this and figured out a little bit more robust version of this. Because one of the things that I need to do as I'm developing more sophisticated features is I need to be able to integrate GenAI into my application's UI. It can't just be a wall of text. And so here you can see that I provide an input schema where I take a description and optional image URLs. And I also have an output schema. Prompt and Genkit have built-in support for output conformance, which means that I can just describe the output that I want from the LLM, and Genkit will automatically ensure that the output conforms to it. So here I've said that I want an array of 3 suggested trips, each of which has a title, a description, and an emoji. So I'm going to save that, jump back over to the developer UI, and you can see that in my prompt playground, I already have the pre-filled template. And if I add a description and I say somewhere snowy in the mountains, that automatically fills in to the prompt as I type. And I can run this. And now, again, because I supplied this output schema, I'm not just going to get text back. Instead, I'm going to get JSON back. So you can see that the model output structured JSON in exactly the shape that I wanted, which means that I can parse and use it inside my code. So that's pretty cool, and I feel like I'm on my way to having this dream vacation feature. But there's a little bit of a problem. I have a database full of vacation destinations, but right now, Gemini is just suggesting whatever locations happen to make sense to it based on my prompt. I need to make sure that the output of Gemini matches the available destinations in my database. To do that, we need to talk a little bit about how LLMs work. Because LLMs are not magic. You can't just tell an LLM to suggest something and know for sure that the output that it has is reliable and accurate. Because LLMs are essentially the world's most sophisticated autocomplete machine. They use their massive amounts of training data to anticipate what comes next in a series of sequence of text. And it is amazing how far that you can get, but LLMs need the right context to accurately ground their responses in real-world data. Let's explain this a little bit more by analogy. I love sushi, and I've heard that there's a new sushi restaurant in town, and I want to know what's the best thing that I should order when I go there. I have a friend who loves sushi, and so I ask her, hey, what should I get at that new sushi place? And she says, oh, sorry, I don't know. I haven't been to that sushi place. Now, that's a reasonable response, and I might be disappointed that I didn't get an answer back, but at least I'm not being steered wrong. If I asked an LLM the same question, it might say, hey, you should go try the salmon nigiri. Now, it might be the case that the new sushi place has amazing salmon nigiri, or it might also be the case that it's not even on the menu. The LLM doesn't know what it doesn't know because it doesn't have the appropriate context. And so for it to just make up an answer and sort of give me a fictional version of what I might want to hear is not exactly what I'm looking for. So how do we make an LLM give us actual accurate answers based on real data? That's using a technique called retrieval augmented generation, or RAG. Now, this is one of those terms that almost scared me away from using generative AI because it sounds really fancy and intimidating. But the reality is it's very simple. In a normal LLM call, you have a prompt, you call the LLM provides an output. Retrieval augmented generation adds one extra step. You take the prompt, you use that prompt to retrieve data, you send both the original prompt and the retrieved data to the LLM, and then you get output that is grounded in the retrieved data. Because you specifically instruct the LLM, use only the output in this context to answer the question. How do we bring arbitrary queries from the user? So remember, the user can enter whatever text they want, and they can even submit images, and turn that into something that we can search a database for. That's where vector embeddings come in, and vector similarity search is the technique that we use. Now, what is an embedding? And what is a vector? Well, as far as we're concerned today, a vector is just a big array of numbers. And you can think of it as kind of plotting points on a chart. So if I have a simple 2D vector, I could plot emoji on there. And an embedding model is something that takes input from a user and sort of plots it into this vector space. So if I'm plotting emoji, I could plot a palm tree and it's over there, a mountain is over here, and a museum is down there. And when I plot additional things, they're going to show up near to things that they're similar to, because that's how embedding models work. So a volleyball is going to be closer to the palm tree than the mountain, and a skier is going to be closer to the mountain than the museum. Now, in a database like Postgres, we can perform vector similarity search to find the closest items within that vector space and say, hey, the skier is closer to the mountain. So if I say that I want skiing, I'm probably looking for a mountain vacation as opposed to a beach vacation. That's how vector similarity search works, and that's what we're going to integrate into our application now. Okay, so jumping back here, I'm going to show you our dream vacation flow. And here we have a flow. A flow in Genkit is basically how you encapsulate a task or behavior that you want to have in your application. It has an input schema and an output schema, and in between you can perform an arbitrary amount of code that gets the job done. So for our dream vacation, we're going to implement 3 steps. First, we're going to process the user's inspiration and turn it into a vector that we can search in our database. Then we're going to search our database for that vector, and finally we're going to combine the returned data with the original inspiration in a new prompt that will suggest 3 trips to the user. Now I'm going to start with step 2 because we need to understand how we can actually search vector data in our database. So I'm going to go back to my schema again, and this time I'm going to add a new field called embedding. Now embeddings have to be a fixed size in the database based on the model that is providing them. And I happen to know that the Vertex AI embedding model that Data Connect uses has 768 dimensions. So I'm going to save that, and if we go to our output, we can see that I've added a new column to my database. And now we need to actually be able to insert and query this data. So first, we need to populate this. What are we going to put in this embedding field? Well, I already have a field for each destination that describes what that destination is known for. And that seems like a pretty good bet if I'm looking to find similar vacation destinations to each other. So if I jump back to my queries, I have this mutation called create destination. Data Connect has first-class embeddings built in to the schema model. And so just by defining that vector field, I have this embedding field, and we have, again, a server value, this time called embed. By calling the embed server value, I can specify text and an embedding model, and it will create an embedding and store it in the database. So when I'm creating a destination and I want to insert new data, I insert the known for as normal as a field, and I also insert the embedding server value. I insert these at the same time. The client only has to supply one of these. Something that's unique about Data Connect that I haven't mentioned yet is that all of the queries that your application calls are predefined before anyone ever actually uses your application. That means that even though this rich query model is capable of pulling any data from my database, only the specific fields that I have selected to return and only the exact variables that I have opted to allow users to fill out are able to be called from the client. This creates a security model that feels closer to writing custom server code. When you write custom server code, you build an endpoint, you check authentication. That's what we're doing here, which in our case is public because this is just a public landing page query. Then you decide what kind of data you need to fetch based on parameters that are passed into the query, like those up here. And then finally, you decide what data that you need to return. So each one of these queries is almost like building a custom server endpoint, except you don't have to write any of the code, and we also give you an SDK for it. So now we're going to build a new query to search our destinations. We're going to take a string from the user, and we're also going to take an optional limit. And let's set the default to 10. And so now we're going to query using semantic similarity search. So I have destinations, and again, you can see in the autocomplete that because I have an embedding field, that shows up as an item in my fields, and I can perform a similarity search. I'm going to compare it using an embedding to the passed-in query, and I'm going to use the Vertex AI text embedding gecko model, which is built into Data Connect. Now I need to set a limit. And finally, I need to select what I'm returning. So I'm going to search my destinations, and you know what? I'm just going to pull all of the same stuff that's up here. I also want to make sure that I pull the ref because I need to be able to access this. I need to be able to reference which ID I'm talking about. Okay, so if I try to run this, I'm going to get an error. If I try to add query a sandy beach, I'm going to get an error again. Or actually, I'm going to get, interesting. I haven't actually populated the embeddings yet. And so the results that I'm getting here, I'm assuming are just kind of random based on what happens when you have an empty thing. But I can populate those using a script that I've already written. And that's just going to go through and populate the vector embeddings into each destination in my database. And now, if I search for a sandy beach, you can see that my results are looking pretty good. Island, the tags are beach, beach, beach. All right. I think I've got something that's working pretty well for similarity search. Now, this is just a 3-word prompt, but it could be anything. You could type arbitrary text here, and it would find the nearest items in the database. But you want to have items that are similar to what your data looks like, because the whole idea is that you're doing a semantic similarity search. So going back to my dream vacation flow, I'm now ready to process my inspiration. And this is a prompt that is using the limitations of LLMs in their favor. So if I look at my inspiration prompt, I'm taking the description and image URLs using Gemini Multimodal, and I'm basically saying, write a fictional description of a place that would be amazing based on the inspiration that the user has provided. So this doesn't have to be real because the point isn't to get an accurate description of a real location. It's to have something that is semantically similar to entries that are already in my database. So I take this inspiration and I bring that into my code. So I just say, I'm going to wait for my inspiration prompt, pass in the input, and then I'm going to get a description of the location that I want out of the text. Next, I need to be able to actually perform the vector search. For that, we need to use a retriever. A retriever is basically something that allows you to map an arbitrary data source into something that an LLM can easily understand. So what I want is a destination retriever that I've yet to implement. And I'll just go ahead and drop in the implementation. And once again, because I defined that search destinations query, this is as simple as auto-completing an import and passing in passing in the variables for it. I then return the destinations, and using this define simple retriever that comes with Genkit, I can say the text content that I actually care about the LLM reading is in the known for column of the response. So I'm going to save that, go back to my flow, and now I'm going to implement step 2, which retrieves the destinations from the vector store using the retrieve method that comes with Genkit. So I use the destination retriever that I just defined. I pass in the description as a query, and I say that I want a limit of 10 results returned. That's step 2. And now we're on to step 3, where we actually generate the trip ideas. Now, if you recall, I already have a pretty good prompt for that. But I just need to add the grounding context. To do that, I'm going to add one item here. I'm going to say ref string the ID of the destination from the provided context. Save that. I'm going to go back here and use that prompt, pass in the description, and now I'm passing a second argument. I'm passing context. So I can just take the direct results of the retriever, pass them in as context, and with nothing more than that, I have now grounded my generation in the data of my database. And with that, I should have everything that I need to run this end to end. So let's go back to our Genkit UI and try it out. I'm going to go to my dream vacation flow, and I'm going to say somewhere snowy with great skiing, and I'm going to hit run. Now again, you don't have to think of this as being different from building any other type of feature. I took it step by step. I broke it down into a few prompts. LLMs are knowledge processors. You can think of an LLM as being a way to take unstructured data and turning it into something that you can actually work with. They're really great at that. And that's what I've taken advantage of here in building out my feature. So now I'm getting an error, and I believe I know what that is. It is because I forgot to add authorization to this. So I'm going to make this public just to make it easy to test. But in general, Data Connect only allows you to use an authorized user, and you can pick the level. So you can say that this is public, this can only be accessed by verified users, anonymous users, or all users. So again, I'll make this public, hit save, make sure that it's refreshed, and let's try this one more time. All right, looks like I've got another error. Let's check it out. Actually, I'm going to use this as an opportunity to show you another feature of Genkit, which is that in addition to letting you play around with things, it also lets you trace things. So I'm going to go to View Trace, and you can see that it steps through what I've implemented, and I can see, okay, here's my first step, and that just generated my inspiration, and there, that worked fine, but my second step had an error. So I have cannot read properties of undefined. This was my query, and there is no output available. All right, so the problem was somewhere in the retriever. Let's take a look at our retriever. That looks all right to me. Let's test our query out. We run that locally. All right, that's returning fine. That's all right. So let me actually just there we go. All right. I've reset this to a known good point just in case I made a mistake here. We're going to restart Genkit as well. Try this one more time. There we go. All right, let's try our dream vacation flow one more time. A snowy place with great skiing. All right, so it's going through our steps. First, it's processing our inspiration. It's sending that to the vector database, and then it's sending that to generate these 3 trip ideas with output conformance. And there you go. I must have made a mistake somewhere along the way, just a little coding mishap. But you can see that we have the Swiss Alps, the French Alps, and the Japanese Alps. Wow, it really likes the Alps for this, which I guess makes sense. That seems like a great place for skiing. If I go back to my trace, this time you can see all 3 steps. You can see first, it processed my inspiration, it retrieved 10 destinations from my database, and then Gemini selected 3 of those to compose my final response. So this is all great. Let's bring it into my app and deploy it. So I'm going to go back to my app. I'm going to take this off. Oh, sorry, I'm going to leave that there. And again, my UI team is great. They keep working ahead of me and everything's just set up and ready to go. So I just got to uncomment this, save it. If we go back to the home page, we'll see that now instead of the Find My Trip button, oops, got to go the other way. We're going to see Plan My Dream Trip with AI. Okay, so that's what I want. But before I do the big finale, let's deploy this to prod. So what's the first thing I'm going to do when it's time to deploy? Of course, I need to commit everything I'm doing. And I need to push to that to my Git repo. Next, I need to deploy it. So I'm going to type Firebase deploy. And this is going to compare my local schema that I've defined with Data Connect to my production schema that I have, and it's going to look for any differences. Now, I suspected this might happen. Since I jumped straight to the end, it's actually pointing at a different database that already has all of my changes. So I'm going to show you an example of what this would look like if I removed these and hit deploy. We want to make sure that anytime you're deploying to prod, you have full control. Oh, right, I can't just remove things. Let's add another thing. Hello, Boolean. We want to make sure that you have full control anytime you're deploying to prod. And so we're going to compare the schemas. We're going to look for both safe and unsafe changes. And we're going to prompt you as to whether you want to make those changes in your production environment. So here you can see that my new schema is incompatible with the existing database, and it tells me that I need to add a column hello. Well, I don't actually want to do that because I was just doing this for an example, so I'm going to abort out of that. Now, I've deployed my database schema. I've deployed my GraphQL schema and connectors to Data Connect. So lastly, I need to deploy my web application. Except I've already done that because, as I told you, app hosting deploys as soon as you push to Git. So as soon as I pushed my repo to Git earlier, that started an app hosting deploy. So let's take a look at the app hosting dashboard. And we can see that we have a build in progress. And so that's going to go ahead and build and push my app to production. And now, using the magic of demos, we're going to switch to the final version that's already been deployed. And we're going to plan our dream trip with AI. So again, I can write anything here. I can also add images. Let's say that I'm looking for a little bit of culture, and I want to go somewhere with a lot of museums. I'm going to plan my dream trip, and that is just going to run the flow that we've just built. Process inspiration, vector search for similar destinations, and then suggest 3 destinations. And because I have structured output, I can build a beautiful UI that incorporates the arbitrary data generated by the LLM with existing data like the images from the destinations in my database. So here we have Viennese waltz vibes as a suggested trip, or perhaps you'd prefer Prague's picturesque passage, or maybe Bruges' bewitching beauty. You might have noticed that I prompted for alliteration in my vacation titles. Each one also comes with a fun little emoji to describe the vacation. So in just a short amount of time, I've gone from a kind of drab onboarding flow that didn't have much of a call to action and added 2 new features that I hope will bring users in. First, featured destinations powered by Data Connect and relational queries. And second, a dream vacation planner that uses any input from the user and suggests real trips based on actual destinations in my database. So let's wrap up. I've showed you 3 new products today working together. We have Firebase Data Connect, our first relational database offering that offers a new way to think about backend as a service. You define your queries ahead of time, and we do the rest. We think of it as a self-driving app server. I showed you Firebase Genkit, something that makes building with GenAI accessible and approachable for any developer. And we built a complex flow that uses retrieval augmented generation to pull results from my actual database using Data Connect's vector search capabilities. And then finally, while I didn't spend a lot of time on it, app hosting just kind of did its job and got out of the way. I pushed to Git, it built the application, it deployed it to a URL, and it just worked. And that's what I'm really looking for in a hosting provider. I want it to just work. So at Firebase, our entire job is to take hard things in development and make them accessible. And we think that with these 3 new products that we've launched at Google I/O, you'll be able to incorporate GenAI into your applications and build things faster and better than ever. Thank you very much.